Nerve center trap masks enable nerve center to focus on events of interest. We do that by filtering on any of the following or all of the following: a generic trap number, a specific trap number, an enterprise ID, and most importantly, and this is why it's in the bold, information from the variable bindings. Generic traps are 0 through 5. Every device typically emits them in a generic fashion, and there's a list of what they are. I'm sure it's coming up here shortly. I don't remember them offhand, but they're easy to remember. There's also a specific trap number. I could receive a 1361419116226. That's a Cisco trap. And it could have a specific, that's the OID, by the way, Cisco OID. And it could have a specific trap number of 32. And I could write a trap mask to capture exactly that trap and only that trap from the 1361419 blah 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 32. Exactly and only that trap. And then I can interrogate the variable bindings for additional information. Or I can simply write a trap that says if any device on the network emits a link down, it's a trap that I want to hear. So we can filter very generically or extremely specifically. Depends on how you want to use the information. Let's take a look at how this is done. We do this by going to the mask field, opening the masks, keying in new, and we start filling in the information. Now the first thing to fill in is the name. Up here, you put in the name. In this case, it's being called a link down. Then you jump down here to the middle section where it says the ICMP version. And you select whether it's a version 1 or a version 2C or a V3. Then you go to the pull down below it and you choose whether it's generic and its generic number. In this case, a link down is a 2 generic. If it was an enterprise specific, that number would become a 6. And then you would fill in the specific number in the field specific down below. In this case, we've chosen that it's a generic link down. So therefore, the specific field remains a -1, which says all. There's no specific traps after that. It's just looking for this 2. And then the last thing we do is we go over to the right-hand side and we decide the type of trigger to fire, whether we use a trigger function or a simple trigger. Now a simple trigger says I have all the information I need right here on this page to fire a new trigger called link down, and I type in the name link down. And I can save that, and I now have a mask that is looking for any link down coming from the network. Any device on the network that's in my node list issues a link down, this trap will catch it. A simple trigger. What if I chose to say there's not enough information in this for me to fire a trigger? In other words, it's a link down, but I want to know some specific interface types or some more information about it before I fire my trigger. Then I would choose the trigger function. I would click the trigger function, and it would put me onto this page. And on this screen, I fill in a Perl expression that needs to be evaluated. And when it evaluates to true, it will fire triggers for me. And in this particular case, I am giving it the Perl expression that says, if the value of varbind 2 is equal to a 2, then I fire a trigger called interface frame PVC is up with a sub-object that is the default value and a default node name. Else, if the value of VB2 is a 3, I will fire a trigger that says interface frame PVC is down. And again, the $ default subobject and the default node name. Now, one of the important things to notice here is the form of a fire trigger statement. This is the syntax you need to know. Fire trigger, bracket, quote, the name, quote, comma. If you are going to give it a subobject, you give it the subobject after the comma. You can pass it the default subobject, which is the subobject of varbind 0 whenever it's a trap. You may want to pass it a different subobject. You may want to pass it the subobject of varbind 12. That you will have to construct here. And you could say VB object of 12. And then comma, the default node. The default node is the node that started this whole thing off. So you can stay with the node that created the initial transition, or you can send it to a different node. Let's say you've got a multi-homed interface, and you have one of the interfaces are a management interface that you do all of your SNMP on, and the other interface is the primary interface to your corporate world. And you don't want to be bugging it with SNMP requests. So you could fire a different node name or IP address here, and it would go to the management channel, focused on the interface that, or whatever it found in varbind 12 as the object of VB12, and it would go interrogate it from that side, leaving your primary side to run. Most cases, this is defaulted all the way through, and all you simply need to write is fire trigger, bracket, quote, trigger name, quote, bracket, semicolon. You don't have to give it the other pieces because it assumes the defaults if you don't have any. But if you put any in, you must put them all in. If you're going to leave the default node, then you don't have to put it in. You just have to do the default subobject or change the subobject, and it will assume the default node. So it's a building block. If it sees a comma, it assumes the first one is the subobject. If it sees a second comma, it assumes the second is a node. If it sees a third comma, it believes there is a delay in seconds. How long do you wish to delay before you fire that trigger? Back here, I fill in the name. I select my SNMP version. I select whether it's a generic or enterprise specific. If it's an enterprise specific, I put in the specific number down there where the -1 is grayed out. And then I decide if it's a trigger function or a simple trigger. Do I need to get more information from the varbind to fire my triggers? If I do, then it's a trigger function. If I don't, if everything is here, then I just give it a simple trigger and I write the name of the simple trigger here. I save it to my database, and now I have a trigger name that I can go build a model with. I go to New. It opens the node definition window for adding a node. I highlight and copy the public DNS name, the EC2 name. I have a list on my other windows. You can copy it from yours. Cut and paste it into the name field. Click on IP lookup. It will find an internal IP address. Highlight it, add it to your list, and say, OK. It's here, and it now has an IP address down here for you. You can go back and change this. In my case, I am the instructor. So I changed it to instructor or something of that nature. And I can save it. And I can see now that instructor is in my list. Some nice little functions from the node list when you right-click. Select a node. Manage it, delete it. You can check its property group or give it a new property group. Have you noticed in your node list that when you assign a new node, it gets assigned to the NerveCenter default property group? We do that to save you the time so that you can come back if you want to and classify it yourself. Or if you're not thinking about it, it gets done for you because it has to have a property group to be in the node list. You're going to write your own trap catcher. And we're going to do that by going to the masks, either there or via admin mask list. It opens the same window. We're going to do a new, and we're going to write a new trap mask. We're going to call this trap mask my, and here's some keys, guys. The names, you cannot use spaces. NerveCenter sees the space as there's an option coming. So you can do my trap catcher with the appropriate uppercase letters, M, T, and C. Or you can do my underscore trap, as long as it's all one string of text. The limitation is 256 characters, so you can pretty much put in a sentence if you need to. For the name, we're going to give it a name. We're going to go down here and select the version. By default, it assumes version 1. Notice how the generic field below it is not populated. If I use the pull down, I have the ability to choose any of the generics, which are 0 through 5, or I can tell it that it's an enterprise specific of a 6, or I can just say all traps, the -1. And in that way, when I select all traps as a -1, it's going to take any trap that comes into NerveCenter that has a node in its node list and catch it. It's going to catch it. It's going to evaluate it. And then what is it going to do? Well, it's going to go right over here and it's going to do a simple trigger, because I get everything I need with just that little bit of information. Any trap that comes in will fire this new simple trigger. And I get to name this new trigger. I'm going to name it my all traps. And again, the same situation here. Uppercase, lowercase, no spaces. It assumes an option is being passed. You can use hyphens, you can use underscores. You cannot use exclamation points or % signs or any of those other fancy pieces. And I now have a trap named, a mask named my trap catcher that's going to catch all traps that come into the server as a version 1. And when they come in, it's going to fire a simple trigger called my all traps. I'm going to save it. I actually like to save these things even twice. And then I'm going to turn it on, and I'm going to save it in its on state. It is now written and waiting. Waiting for what? A pending transition. A pending transition for what? For a trigger named my all traps. Have I written the alarm yet? No, I haven't. Let's go write the alarm. First, let's expand a little bit on this trap mask list, and you'll notice that now I have a new mask in that list called my trap catcher. It's turned on. Its type of trap is all traps. And its trigger name is my all traps. It's now in my database. It's there. It's ready to go. I can now go write an alarm using my all traps. Let's do that. I'll close the mask, close the node list at this moment, and I will go to the alarm list. Now I can go here and choose alarm definition list, or I can go here to the little blue bells. It's the same place. It's the same exact place. I'm going to do a new alarm. And I now have an empty alarm definition window in front of me that I get to fill in. How do I fill it in? What do I need to do? The first thing I need to do is give it a name. What is it going to be doing? This is going to catch my all traps, isn't it? So why don't I name it my all traps? Makes sense? It's following along with the naming convention I started. Got no spaces. Then the property. For most of this class, we will be leaving the property as no prop. And basically that means that it doesn't have to have a property in the property group assigned to this. We'll talk about the property group assignments later. But for now, leave it at no prop. And the scope is set to node. I want to know when any node on my network sends a trap. So I will leave this at node scope. What do I do next? I go up here to the definition field. And the first thing I like to do is, can you notice you can't see the word ground completely? Right-click, and you can change the size of that icon. Make it just big enough to see the word ground so that you can read what you're writing in there. You can place it anywhere you want to now. Doesn't matter. You're designing this. So what's the first thing I got to do after this? Well, I've got ground. It needs to go to a new state. So I'll go here to the blue oval, and I will click State Definition. And I get to define a new state. What's the name of the state we should use? Anybody got an idea what I'm going to call mine? My all traps. That's the name I'm going to give this state. What's its severity? Is it critical? Is it major? Is it minor? Is it normal? Or is it special? I'm going to choose special because I think it's a special state today. And I click OK, and it adds it. It adds it to the definition field for me to start moving. And I can move it all over the place now. I can make this thing look as good or crazy as I want to. Again, notice not quite the size I want, so I can size it just a little bit more just to be happy. You size one, it affects all of the sizes, all of them on the same display. Only on that one alarm, though. All right, so now I've got a ground state, and I've got a state defined as my all traps, and it's a special state, right? And I need to get to that state. So now I need to define a transition. A transition based on the trigger I wrote called my all traps. So how do I do the transition? How do I define a transition? By using the rectangle at the top. I click on it, and it opens the transition definition window, where I get to select where I'm coming from, the ground state. I'm going to the my all traps state, and then I get to select from the list what name. Probably should be my all traps, because that's the one I wrote and that's the one I want. I don't want anybody else's. I don't know what the link timer does. I don't know what exam does. I mean, God, look at all the other possibilities in here that are trigger names. You don't know what they're for, so don't use them. Use your own. They're for other models, things that have been designed by somebody else. You've got my all traps in there. You say OK. You OK that, and lo and behold, it adds that transition for you. Now notice when I right-click on the transition, I can change its size. I can move it all over the place. I can do all kinds of things with it. Also, when I right-click on it, it says masks. And that is telling me that this trigger name is generated from a mask. And when I highlight the masks, it tells me that mask is my trap catcher. And if I click on it, it opens the mask. It ties all the pieces together for me. As long as I do it right, it ties them all together. I can follow it through and find out where everything comes from this way. Whether it's a mask or a pole, a subroutine, whatever. Great. So I come from ground, I come off of my all traps, and I go to this state called my all traps. What's going to happen here? Let's think about this logic. I have a mask turned on. A trap comes into the server, and it's going to evaluate to true, and it's going to fire this trigger, and it's going to transition me from ground to my all traps. And it's going to wait there for what? A pending transition. Do I have a pending transition here? There's no way out of this state, is there? There's no way to get out of here. So what's going to happen is it's going to dead end right now. It's going to catch one trap, and it's going to dead end. Well, what if I wanted it to catch multiple traps? What if I wanted it to keep catching these traps for as long as it's turned on? What if I want it to log that information to a file so I can see what the contents of that trap is? Well, the first thing I should probably do is think about the logging to file. If I run through this trigger and I double click on it, I can see there is no actions. This section is empty. There are no actions during this transition. I'm going to add an action down here under this new action pull down that says log to file. And when I click on it, it opens a window that gives me the ability to name that log file. Well, since the trap is my all traps, and the model is my all traps, and the trigger is my all traps, I guess I'm going to call the log file my all traps.log. And I'm going to leave it in the default data configuration, so it will log a set of default data, which is a pretty complex and complete set of data. It's typical to leave it in the default. But if I wanted to customize my set of data, and I didn't like what was in the default, I would unclick the default. I would go to this special symbol list, and I would pick from this list these NerveCenter variables that I want put into it. Let's see. I'm probably going to want to put the alarm name in there, and I'll hit this red arrow, and it will add it. I'm probably going to want to keep the time that it was transitioned at, and I'll put that in there. And I'm probably going to want to keep, let's see, where did it start from? That's called the originating state, right there. That's the state that it started from. And it went to a destination state. So that's that one, and I'll add that. And I can keep adding NerveCenter variables until I complete the list as I wish to have it. Or I can use the default, and you say, okay, that wrote it to the cache. Okay, wrote it to this display. But it is not available yet to the database until I do what? Until I hit the Save button here. Now, all of that information has been written to the database. That's why you hear me say save, save, and save again. It usually takes okay that, okay this, and save for it to be written to the database. Now, if I double-click on that same transition, I have an action here for a log to file. And I can double-click on it and see the file that it's going to log to, the default format, etc. I have a log to file action. Great. I get one trap, it fires this trigger, I go to this state, and I'm waiting forever. If another trap comes in, I'm not going to catch it because I have no pending transition, do I? So let's think about this. How can I make a pending transition, not sit here and wait, and not go to another state or another state or another state and keep building states? Why don't I do a transition that loops? A new transition that will loop from my all traps back to my all traps on my all traps and say there. I'll come to this state on the first one, and any other one that comes in after that will loop, goes out of the state, comes back in, and as soon as it goes out and comes back in, it re-energizes the state and waits for its next pending transition. So I can catch as many traps as I want to. What do I need to do? Well, I have over here a log to file called myalltraps.log. So let's just copy that. And we'll go here and we'll give it the same log to file, myalltraps, and we'll say OK, OK, and save. And now I have an alarm definition that will come off of ground and go into memory on its first transition. It will log to a file called myalltraps the information that it gets on that transition. And any time that a subsequent trap comes in, it will loop on this transition, and it will also log to the file the same information every time, or whatever information is in that new trap. I've just built a two-state, two-transition basic alarm definition. When I turn on my mask, and I turn this on, and I manage the nodes in my node list, this becomes a simple behavioral model. It becomes a simple behavioral model that has a couple of components, a mask and a simple alarm. This particular behavioral model is a very, very handy tool, because anytime you have an issue with traps on your network, you can go turn this on, let it catch 2, 3, 4 of the traps, and then you can go look at the log file and interrogate the information in there and see what's coming in that trap. Decide if you wish to use it, not how you want to use it, what information is available. You can interrogate the trap and make your determination. So this is the first piece of the toolkit, writing a mask, building an alarm, and using it as a tool to catch all traps on your network. I'm going to go back to the alarm definition window. I'm going to turn my all traps off. Watch my upper alarm summary display when I turn this off. Did you see the alarm disappear? It disappeared because when I turn it off, there's no more pending transition, so it goes back to ground. Ground isn't tracked, so it comes out of memory. I don't see it. It's gone. How do I know I have something? Because I have some log files. And I will set up and go show you what's in my log file. I suggest you don't let it run too long, because it will fill up your log file on you, and it will make it difficult to read the log file if it keeps filling up. If you were on a Linux or Unix server in your normal environment, this is where you would be. You would cd2/ops/osi and c/user files/logs. And you can see I have a file here called myalltrap.log. Where did that come from? It came from me doing a log to file on an action on a transition. If I do a more on it, or a lookup, I can see I have a bunch of entries in here. It starts here with the time. Let me do this. Edit mark. It starts here at the time, and it goes all the way down to this final section. There's the whole, that's one single entry for the log file. And it says the time, the date, the ID in the logs. These log IDs get zeroed out when NerveCenter is started, and they continue to increase until NerveCenter is restarted. So you may have a log ID of, 100,000 something. It doesn't matter. It's just a continuous running entry number. It gives me the destination state's severity. the node's property group, the node's name, the alarm's name, the originating state that was ground, the name of the trigger that transitioned me. Trigger name is my all traps. The destination state was my all traps. The trap PDU specific time that the trap generated was that number. It's a Unix type of timestamp. The trap generic number is a 6. Well, a 6 doesn't mean generic. It means it's specific, doesn't it? When we look at that list, 0 through 5 are generic. 6 was enterprise specific. So there should be an enterprise number right here. Trap PDU enterprise 136.141.99999. That's the OID of the vendor that sent it. The trap specific number is a 40. The trap instance, the trigger instance, is the 0 instance the first time. The base object for the trigger is system. The attribute. What's an attribute? This, people, is where your varbinds start. The word attribute is synonymous with varbinds. So the first varbind is system description.0, and it is equal to acme.com hubomatic. The second attribute, or VB2, is based off of ifdescription.1. This is a subobject, right? ifdesker.1. The description is hubomatic Ethernet 1. And the third and final attribute, or varbind, is the interface input errors on interface 1.1 is equal to 32. This trap is telling me that the vendor-specific device of 4 nines got a trap specific of 40, and that trap specific of 40 contains interface input errors for interface 1, and the number of those errors is it's had 32 of them. You've seen how we create a trap mask, turn it on, use the trigger name that we give it to create an alarm and the alarm definition list and make transitions and add states. To the transitions, we added an action for logging to file, and we are able to look at that log to file and read it and find out that it comes from the acme.com hubomatic, and it's telling us we have input errors on the interface 1 and that there are 32 of them. So based on this trap, I could foresee us creating a model that takes this information and goes off and polls interface 1 on this specific node for a set of errors to see if there's an error. And I would do it with a delta that says, let me go poll the delta. I've got a 2-minute poll, so it's going to poll for the first time. Because it's a delta, it's going to wait till it gets the second poll so it can do the difference between the two. It's going to calculate that difference, and I'm going to say if the delta in the input errors is greater than 10, fire a trigger, errors too high. And I got a new alarm that goes off and says, yep, the errors are too high on this interface, what do I want to do with it? And I might say, if the errors are too high, send an inform over to the NOC, to the netcool machine that I'm having high error rate on a machine, and at the same time, cut a ticket to remedy for somebody to go out there and take a look at this interface. And I did it by catching this trap, reading through the trap information, using the specific information to fire a new trigger in a new situation with a poll focused on interface 1 for input errors. Based on what we saw, or that we could read here in this trap, I caught this trap with my simple little tool now called this all trap catcher. And I look at it and I go, oh, okay, I'm getting input errors on interfaces on this device. I can use that information to create a new model, which I haven't done, but I'm theorizing that we could do this real quickly, that would then go out and ask the actual interface 1 for information about its interface and see if it's getting in a set of input errors. And I would probably base that on a delta. And a delta is a very special poll within NerveCenter that says, I will poll twice before I actually do anything, and I will poll twice based on the poll's frequency that we wrote it, and then in that way I'll get the first base of information, I'll wait for the time to time out, I'll get it the second time, and I will take the difference between the two and use that to evaluate. And I would say if the delta of if entry.if in errors.1 is greater than, let's say, 10 or 20, whatever number we decide is too many errors in a 2-minute period, fire a trigger, errors too high. Else, fire a trigger, errors not high enough. And based on that new poll, I could create a new alarm that would go out and poll, get the delta, and determine if the actual interface errors are too high or if this was just a once in a blue moon situation. I'd want to look at it before I notified the NOC that it was actually high interface errors, wouldn't I? I wouldn't want to say I got a bunch of input errors, in errors on this, there's 32. Oh my God, I got to send it to the NOC. I'll go test it. I'll check it. I'll verify the condition. I'll run a new poll. What's it going to cost me? It's going to cost me a poll, a small alarm, and 2 minutes. If the delta, the difference in that 2-minute poll, is greater than some number I determined to be a high amount of errors, then sure, fire a trigger that it's a high error. On that transition for the new trigger name that's called high errors, I would do an inform to the platform telling NetCool, I got high errors on this device. It would be, we could tell it that it's on Hub-O-Matic, its node name is instructor, and it's interface 1. And we could put all of that into the inform. So I was just taking a natural extension of reading, to me, a natural extension for reading this trap information that I got. So now we're going to be using this all trap catcher we just built to read the traps that I send and do exactly what I just said. Turn that generic information around from an all trap log to file and create a very specific mask that is unique. So why don't we take and do that and create a new mask that is specific to the OID, specific to the trap number, and fire a simple trigger. I have the information in front of me. I can write that new alarm, that new mask. How do I go about it? I'm going to write a new mask, aren't I? So I'm going to start with new. What's the name of it? I'm going to call it Acme Hub Interface Errors because that's what it's telling me, isn't it? I'm going to make sure it's a version 1. I'm going to say it is a enterprise specific. And the specific number was what? It was a 40, wasn't it? Specific number was a 40, right there in the middle. It was a 40. I want to filter on the enterprise, and I want to filter from. And what's the enterprise that I want to filter on? It's right here. 136149999. I'm getting from very generic information, my all traps. I'm now going to create a trap mask for just this trap. And I'm going to give it a simple trigger that says Acme errors. I'm going to save it. So did you see how I went about filling out the trap mask now that I have more specific information? I did the same things. The name, the version. I chose the generic number to be a specific. I entered the specific number from the information I gathered. I went up here and I selected filter on enterprise. I selected from, and I gave it the enterprise OID. So now any Acme device who has an OID of 136.141.999 that generates a specific trap of 40 will generate a trigger called Acme interface errors. I save it, I turn it on, and I close it. It's off. Let me turn it on from here. Okay. I now have a trap mask. I need to create a new behavioral model or complete the behavioral model by completing an alarm definition. So let's go to the alarm list. Let's do new, and let's give it the name of Acme interface errors. That's its name. It's going to go from ground to a special state called Acme underscore error. Bingo. I like to size these things so I can see them. It's going to go from ground to Acme error on right there at the top, Acme interface errors, and I'm going to say OK. Again, I like to size these so I can see them. And what did we do the last time? We did a looping transition, so we kept catching them. I'll do the same thing here. I will loop on Acme error to Acme error on Acme interface, and I'll say OK. Am I done? No. I want to log this to file. I'll go double-click on the transition. I'll add the action of log to file, and I will call it Acme error.log. Save myself the work. I'm going to copy this before I close it. Say OK, say OK. Double-click here. Add the same log to file. Paste it. OK, OK. And now I can save it a couple of times and write that stuff to a database. I now have an alarm called Acme errors, and I have a trap mask called Acme hub interface errors. It's already on. So when I turn on this Acme errors, I should now get a new alarm up here in a couple of seconds whenever that trap comes in. That's just based on these pieces. It does the exact same thing as my all traps, except it does it on an extremely specific basis. Only for this trap. No other trap that comes in will trigger this. Let's see if it gets triggered here. Let's see if it gets triggered. Ba-boom, there's the Acme error. That's the new one. And it got the transition, so it did what it was supposed to do. In 45 seconds, it should go through the second state. Does everybody follow on how I took the information from the log file, transitioned it back to a new mask, and created a very specific mask for only this trap? And when I turn it on, I'm now catching just this specific trap. If I were to send other types of traps, this alarm would not transition. Not unless it came from Acme and it came with a 40 in the specific number. I've got my second transition. My alarm is working. It kind of drives home how important it is to be able to catch the traps the first time, read them, and then use that information to make a very specific trap mask. Here's the property group. It's the first icon. Or I can hit admin and I can go to the property group list. Either way, it's the same location. There's that 3COM ECS MIB. And if you notice here on the right-hand side, these are all of the possibles. Notice that down at the bottom here are additional base objects for something like IF entry, interfaces, NL ping, SNMP, and system. These were added to round out the group so that nodes in the 3COM property group not only respond to the upper portion of this list, meaning all of its base objects, but to base objects for system, ICMP, NL ping, etc. I may want to go out and see what the system description is, and to do a system.sys description poll, I need to have the base object in this property group so that it works against the nodes in there. I have a one here for the Acme hub. Now, notice Hub-O-Matic. That is not a base object. That is a user-defined term by me. I put that in there. How do I do these things? How do I create property groups? How do I make this stuff work? There's three ways. I can create a property group, as Step A says here in the book, Lab 6, Step A. I can create a property group based on an existing property group. Okay, let's see me do that. I'm going to grab the ICMP property group. I highlight it, and in the right-hand side I have two properties, ICMP status and NL ping. They are both base objects. I want a new property group called Stevie. I say copy. I say save. And if I close this and open up the property groups again, Steve is going to be down here. And it now has a new name, and it has copied over the base objects from the previous property group. That's the first way of doing this. Copy an existing one. I can delete this by simply highlighting it, hitting delete, and saving it. It's gone. I can make it again. I can go back here and choose ICMP, Steve, hit copy, hit save, and now it is permanently there. I can verify that again by closing it, reopening it, going down and finding it alphabetically, and the properties are there. So copying an existing one. The second way, or as in Step B, is based on a MIB. If I've created a new MIB, or I've added a new MIB from a vendor, and I've put it into the NerveCenter.mib file, and I've restarted NerveCenter. Did you catch that? Put it into the NerveCenter.mib file and restarted NerveCenter. I didn't just put it in and expect it to be there. You have to stop, change, start when you make MIB changes. Compile your MIB offline on a different system with the entire MIBs directory. Get it to compile. Stop your production machine or your test machine, copy over the appropriate NerveCenter MIB files, which we will talk about, and restart. Why? Because NerveCenter runs off of an image in memory of the MIB. Not off of the disk, not off of a flat file, not any place. It runs out of memory. So when you start NerveCenter, it copies the NerveCenter.mib file into memory, and that's what it runs from. So when you make changes to the MIB file, that's why you need to stop it and restart it. Continuing on how to do a MIB to group. Go down to the lower section and click on MIB to group. As I said, it opens up the MIB to property group window, where here on the left side, it has the names of all the MIBs that have been compiled into this NerveCenter MIB file. There's quite a few different MIBs that have been compiled into this one. Yours will show up in the list, typically alphabetically, the new one that you put in there. DNS Reserve, Etherlink MIB, 4-switch, 4-trap log. We get to choose from that list the name of the MIB we just compiled and then put into the NerveCenter MIB file and restart it with. Let's say we want to take that 4-trap log file. I can leave the property group name down there as 4-trap log file, or I can change it to something that I want to say and have it. Again, no spaces, underscores, hyphens, fine. Call it traps for me. Cannot have space in your group name. Huh, I must have left a space in there. I saved it. Reopen it. It should be there now. Yes, traps for me is now there. That is how you do a MIB to group. You compile the MIB, you install it into NerveCenter MIB, you start the server, and you do a MIB to group. That makes these base objects over here on the right-hand side available in the NerveCenter.mib so that NerveCenter polls can work with them. So we've seen how from method A I can create from an existing one. From method B I can create from a MIB to group. Method C is to create a completely new one from scratch. I want to do a new one. New group. I do a save. I add it, actually. Sorry. And now I have it in the left-hand side as new group, but there are no properties in the right-hand side. Let's do that again. Show you what I did. Type in a name and do an add. It puts it in the left-hand list with an empty set of properties on this side. If I tried to save it, it should give me an error telling me that I cannot save an empty property group. So to fill it in, I must put in something, a property, base object, something that I can put in there. My group. I'll add it. That's a user-definable term. It's not a base object to be polled, but it's a user-definable term. Great. What else do I want to do? I want to do system variables. Spell it correctly. I'll add system to it. By the way, it is case sensitive, so if it is system with an uppercase in the MIB, you need to have it the same way here or it will not match. ICMP is another one. ICMP. I can add it. I can sit here and build it. Acme. Pub-o-matic. I can add it. When I'm done adding, I save. And now I have a property group called new group, and it has the properties that show on the right-hand side. This diagram shows us that we are watching for high line card to happen, and if we get more of them, we get at least 3 of them in 2 minutes, and it's 60 seconds because it could actually wait 59 seconds before it gets the second trap, and 59, so it's literally 2 seconds less than 2 minutes is what this times out to be. How do we do it? We do it with, as I said, a new fire trigger action in the actions list. We give it a name, we give it the time, and we can leave the sub-object and the node and the property stuff all basic default because it will match what started the alarm. What other things can happen? Well, we can also add an action in there for clearing triggers. Why would I want to clear a trigger? Well, in the case of the diagram I just did, I would want to actually put a clear trigger on this transition here, the looping transition, because, and let's think about this, I'm in ground, I get a trap, I come to this state, I set a timer counting for 60 seconds to take me back to ground. At 30 seconds, I get a new trigger. I get a new all traps. So I loop. I come back. I'm in this state. I set that timer to 60 seconds. What happened to the timer that was there before it? The one that this guy started. It could still be residual. It usually takes the server more than a second or two to clear these things. And in the case of a looping transition, it's back there too fast. It's going to have a residual counter or timer, residual timer that's still ticking down, just probably got 15, 20 seconds left. And you're going to set a new one. So to avoid having residual timers, you make a clear trigger action by double-clicking on the transition, adding a new action, and the new action is a clear trigger action. And what's the trigger we're going to clear? we're going to clear the trigger called back to ground because that's the one we're timing, right? So we will select it from the list and we will say OK, OK, and save it. And now, if I come off of ground on an all trap and I set a timer and I get another all trap immediately, on the looping transition, I'm going to clear the residual trigger and set a new timer to 60 seconds. How do I know it's going to happen that way? If I double-click on the transition, you will see that the clear trigger comes to the top. One of the things you need to remember about NerveCenter, in the transition definition list of all these actions, the only action that takes a precedence is the clear trigger. The rest of the actions can happen in any order, but a clear trigger will always happen first if it's in the list. And if there are multiples, it will fire the multiples. Before any other action gets taken, it will clear the trigger. So it will make sure that residual is gone before it tries to set a new timer to 60 seconds. Rule of thumb, if you're writing a timer, you should clear it when you come back to that state. Do I have to clear it when I come from ground into that state? No, I've been in ground. There's nothing in memory. I shouldn't have to clear it. If you want to practice rule of thumb, sure. Let's go here and let's put a new action for the clear trigger, and we'll select the same clear trigger back to ground. We'll say OK, OK, and we'll save it. And then we've met the standard practice that if we set a timer, we clear the timer. And it'll be in the list. And it'll always be at the top. The actions below it could be in any order and will be taken in any order. But the clear trigger is at the top, and it'll always be at the top and takes precedence over any other action. Another possible action that we can do in a nerve center transition is an inform. An inform to either a NerveCenter platform, an OpenView platform, a NetCool platform, or something else that's prepared to talk to NerveCenter and work by accepting our traps. An inform action. In the original diagram, where would I want to inform? I would probably want to make my inform on this transition from state 2 to state 3. Because that's the one where I have a problem. I know my severity level has gone from warm blue to warm yellow to red. I'm in a serious, a high-level situation, and that's probably where I would want to do my inform. Let's look at the NerveCenter model that we were just playing with. I could send an inform in this transition or in the other one. Wouldn't matter, because at this point I'm not getting to a severity state. I'm just counting these things and looking at them. And this is how I would add an inform in this transition. By double-clicking on it, new action, and I would do an inform. And the specific number of the inform would be something that you would have to figure out according to the platforms that you're working with. How do I do that? Well, let's hit the help button. Love my online help. Inform. Once NerveCenter has used its event correlation abilities to detect, it can do an inform. To add an inform to an action transition. Inform specific numbers right there. Type a number normally between the range of 100,000 and 199,999. Those are the normal ranges. Here's what specific numbers can do for you, and there's information here. The whole point is you get to choose what you put in here according to your usage, according to the number. So here's where you put the inform in. 100,199. And you say OK, and you say OK, and you save it, and it's ready to do an inform. While I'm talking about informs, we should make sure the server is set up to do informs. Where do we make that? We make that determination from the admin. Log into the administrator. You might want to size it so that you can see it. We have a tab Inform configuration tab. We click on that tab. I have nothing here in the list, so there are no inform recipients ready to go for me. I'm going to send informs to myself at this moment. So I will put in the number 58.132. That's the machine number of my machine. What type of informs am I going to be doing? Am I going to be doing NetCool informs or NerveCenter Command Center OpenView informs? I have to select those. Depending upon which one you select, there is a set of port numbers that need to match here. 6024 is for OpenView. You need to read the help again, and we will take a look at Inform Configuration tab field variables, the port numbers. Enter the port number that your NerveCenter server will use to send the informs to the recipient host. 32505 to send informs to another NerveCenter server. 6024 to go to OpenView's platform adapter. 32509 to send them to a Tivoli NetCool. So I want 32505 in my case. So I'm going to change this to 32505 because I'm going to send it back to a NerveCenter. Now the next thing you need to check is the event notify on. Event only, symbol only. Here's what happens. When NerveCenter sends an inform to NetCool or to NerveCenter, it is an event only inform because we don't change symbol colors. However, if I were going to a OpenView platform for HP, I have the choice to do either or both. An inform to OpenView can do both event and symbol changes. In other words, the event gets sent to the event logger, and the symbol will change the color of the symbol in the OpenView presentation. So when you do your integration and you're with OpenView, read the integration information because there are a couple of steps you need to take on the OpenView side to make this inform with symbol color change work on that side. In our case, we're going to be doing an event only. The next field is minimum severity. I leave this at 0 because I want even the smallest level of information to be accounted for. I could change this up to a 6 or a 7, and then only events that have a severity of 6, 7, and higher are going to be sent, and all the lower level ones aren't going to be sent. You might want to change the level that gets sent here. Properties gives me the ability to choose a specific set of properties that must be accounted for in the alarm before this inform gets sent. And I can build that property list by looking at the help and typing in the $ properties and stuff that I want. And then to complete this, I do an add. It adds this information to the recipient list so that the server, the NerveCenter server, will now have an IP address. It's going to know whether it's doing event and symbol only, and whether it's a NetCool or a NerveCenter OpenView. And I'm going to add that. And the data was saved successfully. And now my NerveCenter server is going to be capable of sending informs to itself. If I wanted to send it to somebody else's, I could go up here, put in a different machine. So 50.16.81, and I'm going to make him an IVM. And notice when I did that, it changed it all on me. It put the port at 32509. I got to do this over. 50.16.81. Notice it filled in all of the other fields appropriately also when I did a NetCool. All I had to do when I changed it, it went to event only symbol level, and now I can do an add, and it will try to send informs to your machine as if it were a NetCool machine. So Now, back here on this diagram, if I wanted to do an inform to platform, this is the way you choose the numbers that go over to NetCool. Instead of just an inform, you do an inform to platform, and you put your numbers in here. And you say, okay, okay, save, and lo and behold, I'm doing an inform, and notice it says it's a NetCool inform, doesn't it? Okay, so that's where you set it all up, and that's how we set it up. So if there's any questions about setting up an inform or where or when, back to the presentation. So we're doing an inform action. There's one of the other possibilities that we can do here. Now we've just seen how to set it up in the administrator and how to set up one or two of the two possible types of informs. OpenView needs to have a OpenView platform adapter or an OVPA module running on it so that NerveCenter can send to it. NetCool must have a NetCool probe and the NerveCenter PA server application running on it. PA server, platform adapter server, that adapts to the NetCool probe software. Log Matrix is not responsible for the NetCool probe software or the probes. We only sell NerveCenter, and when you install NerveCenter, you get either the OpenView platform adapter or the PA server, depending upon your selections when you do your installation. So in some cases, if your NetCool is on its own server and NerveCenter from NerveCenter, it's a different server, you may have to go start a NerveCenter installation on the NetCool machine and add the platform adapter software there to be tied in with the probe, because it needs to reside on this machine that the NetCool is running on and where the NetCool probe is. So that's informing. Inform platform, that's the NetCool. So to do this, let's take one of my alarms. I will take my all trap, and I want to count when I hit 100 traps. And when I hit 100 traps, I'll have it take me back to ground, okay? To do that, I double-click on the initial transition going into the state. I want to count how many times I've gone through the loop here in the logging state. And I will do a new action, alarm counter action, trap count. I want to set its initial value to a 1, and I say OK. And I OK that, and I now have a counter started. On this looping transition on the logging state, I will open its transition. I will go to the alarm counter, and this time I will select the counter, trap counter. I want it to increment, and it's going to fire too many traps when the value equals something like, in this case, let's say 10. And I say, OK, OK. So, again, on the input, which is this all traps transition from ground to logging, we have an alarm counter. We give it the name, and we set its initial value. That's all we do on the input. On the looping transition, in this case, a simple looping transition, there could be logic that takes us down to a couple of states and comes back in, but on that return into it, we would set the counter so that if we made through that loop too many times, the counter would work. On that transition, we have the alarm counter action, where we have selected the counter name. We've decided to increment this counter. We give it a trigger name called too many traps, and it's going to fire when that count equals 10. And that's okay. And what's going to happen now when we put this into place is it'll come off of ground and go to this state, It'll count once, it'll loop through this loop 9 more times, and when it's done, it will fire this trigger too many traps and take me back to ground. Simple illustration of how we set it up and how it could be used. If I double click on this transition, this looping transition, and I do a set attribute action, I get the set attribute action window that opens. The type object here is node. I can change the node's name, and the list will list all of the nodes in my server, or generic $node, which means all of them. I'll choose student 1. The activity, the attribute that I get to set is whether I wish to manage, work on the property group, or suppress. And notice there's a help button here. And basically it would tell us that to manage would mean to manage or unmanage the node. Property group. We can go in and change the node's property group here automatically. Or we could suppress. And to suppress means we don't send polls to it any longer because we know that it can't be reached, so we suppress the polling. We stop polling it until we're told to unsuppress it, which is another possible action. So if I chose suppress, the value here would be on or off. Those are my choices. If I chose manage, my values are only the opposite of what it currently is. This node is managed, so my choices would be to unmanage it or off. And if I chose suppress, I can turn it on or off. Those are the choices for object type node. The other choices are the alarm, the mask, and the poll. If I choose the alarm, the names list all the alarms that are on my machine. Let's choose this one we wrote as test. The attributes grays out on us, and the only values I have are either to turn it on or off. So when I select the alarm type, I get to select an alarm. I don't believe there is something in here for all alarms. There's no default for all of them that you could use, like a $ alarm or something. And then once I've selected that, I can only set a value for on or off. What would be good about this? If I know that maintenance is going to be happening on a group of machines, or better yet, let's take a look at that heartbeat alarm we did the other day. If I know there's going to be maintenance and I'm going to stop receiving the heartbeat, and I know it's a scheduled maintenance between 7 a.m. and 8 a.m., I can go in here and on that time go in and have an alarm that changes the alarm status from on to off for that period of time so that I'm not expecting to receive the masks, the traps that come in from the heartbeat. And then at the appropriate time have the alarm automatically go back and reset it to on state and start expecting to receive the heartbeats again. Other usages might be to turn off a group of alarms until you know that the servers out there on a server farm have all settled down after a power outage or something. Some customers actually use this to turn off most of their alarms, sometimes in large groups, depending upon the customer based on the hours of days that they're supposed to and not manage these customers. They actually go in on those hours and turn off all the alarms and stop polling them and come back at the appropriate time and turn them back on. So alarms on and off. Masks, again the name and the only values on and off, just like alarms. And the final one is a poll. That's the other two, the list of polls that are on the machine, and then either on or off. And that would determine whether you want to turn the polls on or off at specific times and stop the polling. So the set attribute action. The one that gets the most use is something like node, and you'll set the property group to a new property group. So node, notice I can do it to all nodes. And this particular type of a set attribute action would be a great little thing to have if for some reason you're discovering nodes from traps and they come onto your system and they get put into the NerveCenter default property group when they're new. So you stick a system base object in that property group and you have a little alarm that goes out and it gets the sysObject ID. And based on the sysObject ID, you say if sysObject ID equals 136.1419, set node property group Cisco. Else if sysObject ID equals 136.14.178, set property group NerveCenter, and so on. You can actually take the OID and appropriately set a new node to its property group if you know the OID and you write the poll correctly. And that's what a lot of people will do, is they'll do this, they'll have this set up so that when nodes get automatically discovered, they get thrown into the right property groups and they start being managed immediately. That's the most popular usage for it. The lab is pretty straightforward. The concept is to simply add to the two transitions the appropriate new trigger name with a 0 delay and turn that into an alarm that looks like this. This particular alarm counts and times the bottleneck transitions, the number of times we transition into the bottleneck state. It's a very simple alarm with the ground, bottleneck received, and looping condition that we basically start with a lot of times. A return back to ground if we do not get any more than, if we don't get the 5 conditions inside of 7 minutes. And if we do get the 5 conditions inside of 7 minutes, we go to the transition down to tell the platform. And this way, we eliminate from the original model all of these informs that we used to have in these transitions, the transitions that went into the bottleneck state. Instead of banging the platform with an inform every time that transition was happening, we're going to sit there and count them up and say it's a little more important now. We got 5 and 7 by doing our actual inform in this transition from bottleneck to tell platform. I haven't added it here, but that's where we would add it. And that's all there is to multi-level behavioral models. One other thing that I should mention is in our previous situations, whenever we right-clicked on a transition, it told us where it came from, whether it was a mask or a poll. In the new alarm, when I right-click on the transition, it tells me that the name of the trigger came from an alarm, and it shows me that it came from Lab 8. And if I click on it, it goes back here and shows it to me. So somewhere in this Lab 8 is those triggers causing this second alarm to do the counting of 5 in 7 minutes. There are several times when you would use it, times when it's very handy, and I haven't seen a limit at this point to how deep you can stack these. On an average, 2 and 3 are quite common. I have seen an alarm from a customer that had 7 levels, 7 different alarms, models being controlled all in and of themselves. We do it on the transition with a new fire trigger action, with a new trigger name, and a 0 time. We OK it, we save it, and it creates that trigger name in the database. We come here, and we can now take our transitions, and that trigger name is bottleneck sent to Lab 8. It's now in the list, and I can create transitions, etc., around my model, one controlling the other. Notice in this second model, the actual counter timer, that it goes to a dead-ended state. It waits there. It's not going to go back to ground. This is probably not a good practice in most network environments. Again, it's up to what you guys have set in your environments for practices and rules. Personally, I would probably put a timer going into this state that says, unless this thing is reset in a certain amount of time, an hour, 2 hours, 4 hours, go back to ground and let it recount. And in that way, every, say, 4 hours, if it goes through this thing again, it'll send a second and a third alert over to the platform to say this condition is persistent. You also may be doing something like a ticketing system where a remedy ticket has been cut. Well, I believe something like remedy has the ability to send a trap when the ticket has been closed. You could have that trap come into NerveCenter, create a NerveCenter specific mask for that trap with its specific number, create a specific trigger, and then use that trigger to transition from telling the platform state back to ground, indicating that the condition has been fixed, and resetting it to ground. You could also come down here to this tell platform and set another timer and another looping condition that resends the inform after a 24-hour period or a 4-hour period of being here, and then loops and waits another 4 hours. So there are several things you can do so that it's not dead-ended here. Things that you can do to keep it informing the platform and letting those guys know it's a persistent condition or hasn't been fixed. Or you can send it back to ground in a specific period of time. Or you can have a trap received from your ticketing system that sends it back to ground when it's been repaired. So normally it's not left open-ended or dead-ended like this. There are several ways of dealing with it, and that all depends on your site. We can make a new alarm, and let's call it ping check. First thing I can do is I can create a transition from ground to ground on, what was that called, node alive? Node is alive. And in that way, when this pole runs, every 10 minutes it will loop on ground. Come right out of and go right back into ground. I can do a log to file on that transition, and I can know that every 10 minutes if that node is alive. What are the possibilities of it having gone down? Pretty good, so let's take that into consideration. Let's add a state called node down state. We'll call it a warning state because it's not quite there yet. I want to size it because I hate when it's not big enough to see. And I can transition from ground to node down on, there they are, the ICMP possible built-in triggers. They're in my list. I don't give it the name, I select them. Let's say it's an ICMP timeout that causes this transition. So what's going to happen here is every 10 minutes I'm going to run this poll right here, poll ping node, and if it responds, it will fire the loop, go back to ground, and wait 10 minutes to fire the poll again. If I get an ICMP timeout, however, as a network error response to my requested poll, NerveCenter will retry 3 times with 10 seconds for a total of 40 seconds, and after 40 seconds, it could fire an ICMP timeout, built-in trigger, and that timeout will take us to the state called node down. I didn't have to write the name of the trigger. I just used the built-in trigger for the response to the error. What other possible transitions are there? Let's take a look at what's other for ICMP. ICMP error, ICMP timeout, ICMP unknown error. There aren't too many for ICMP. There are, however, some for SNMP, and these are all of them that are in uppercase. Authorization error, bad value, description error, end of table, general errors, no such name, not in the time window, etc. SNMP timeout, SNMP too big. It's okay because I'm not doing an SNMP request right now. I'm actually doing an ICMP. What could I do next? I could make a transition that looped on node down to node down on, well, let's go back to ground. I think I want to go back to ground. On, what's that, node alive. Node alive. So that if I'm in this state, I can rerun this poll every 10 minutes. If it finally answers, I can go back to ground. If it's not answering, I would have a transition that looped on node down to node down based on, what did we have before? ICMP timeout. Let's go select the same ICMP timeout. Where is it? ICMP timeout. And say OK. And now I've built a nice little alarm that will work with this definition of a poll and keep status on the ICMP components of any device on the network at the node level. Do you see that? I'm going to sit here in ground, and every 10 minutes I'm going to run this poll. If the poll responds, I'm going to loop and go right back to ground and run it again 10 minutes later. If it fails, I'll try multiple times. I'll fire a built-in trigger here, ICMP timeout, to take me to this state called node down. In the node down state, I run this poll. It's the exact same one. Now, this may bother you in that it's going to wait 10 minutes. Potentially what we could do is we could copy this poll, this ping node, and we could call it fast ping node and change it to a 1-minute interval so that instead of waiting 10 minutes up here, it would do it every 1 minute, and that way we would be quickly checking for the ICMP status to return to us. That's how NerveCenter can adjust its polling frequency. It's 10 minutes when it's good. It could become 1 minute when it's bad. Just by copying it and naming it fast and then naming the trigger fast node alive. Changing its speed to its time interval to 1 minute, and it could become a fast poll. NerveCenter runs at 10 minutes until it's an error. When it's an error, it runs at 1 minute. We adjust the polling frequency this way. Another little trick that NerveCenter allows you to do and helps you to know quicker when the node comes back up. And show you quickly how this works. Okay. I am on a server, the NerveCenter installation directory. The NerveCenter installation is /opt/osinc. That is where we install Open Service NerveCenter, OSINC. If I look at it, I have a samples directory Very good place to go. It has samples of log to files, databases, and other things that you can look at and use in your NerveCenter. The binaries, the configuration directory, the database directory, docs, lib, etc, man, so on. Where you want to be is you want to be in MIBs, because that's where all the MIBs are. You must run this in the MIBs directory. Notice there is a mibcomp.txt file there. It happens to be identical in size to mibcomp51.txt, and that is because this is the default text file for a 5.1 installation. There is also a NerveCenter.mib and a NerveCenter 5.1.mib file. They are the same size. That too is a default. We give you a backup copy of the mibcomp.txt and a backup copy of the NerveCenter.mib file that gets installed. Yours may change when you've already made changes to it. This particular one has been compiled with the MIB name map option so that it can use older MIBs. Notice the MIBName map.txt file. Notice we also gave you a default MIBName map 5.1.txt. So this is a compilation with older MIBs using the MIBTool. I'm going to do a MIB compilation using MIBTool and not worry about having any of the older files in there. To do so, MIBTool minus MIBComp, the name of the file that you wish to read, mibcomp.txt. And in this case, I'm going to change its output file. -O changes the name of the output file so that I don't overwrite the existing NerveCenter.mib file. I'm going to change it to something like December 17th, 2010, _1 for rev, and call it .mib. And I hit enter. As you can see, it's loading all of the MIBs that it plans on compiling, and now it's compiling them. And eventually, in just a few seconds, marks the duplicates, and it should write an output file. And it did that entire MIB compilation in 18.724 seconds. That's pretty fast. So now if I look in my directory, I now have a MIB file called December 17th, 2010 _1 for the version that I'm working on, and it's .mib. I can go look at it. I can check it to make sure it compiled the things that I want when it's appropriate, and I know that it does the things that I need it to do. I would stop my server, copy it to NerveCenter.mib, and run it, and restart the server and have this new map. What did it read? It read the mibcomp.txt file. So let's take a quick look at that file. mibcomp.txt. This is the NerveCenter precompiled MIB inclusion file. Anything with a # is not executed. These are all comments at the front. Notice the -O. It assumes the output file as a default to be NerveCenter.mib. So this is where it gets its default. If you want to change this permanently, you would go in here and modify this file and change that -O, and it shouldn't ever write a NerveCenter.mib file for you. Now notice, as it starts going down through, that we have SMI V1 MIBs here. These are the standard RFCs for V1. Those that are commented out aren't included. Those without a # are compiled. And notice that this refers to a directory structure, standard V1, and then the RFC 1213.asn1. All the different standard V1 directories. These are all of the SMI V1 MIBs that are being included. We have included at the far right comments that we know about these, where they're superseded, replaced, what ones they will conflict with. Then we include vendor-specific SMI V1 MIBs. If you have a bunch of old Cisco stuff and they are in the ASN1 format, they need to be included here before you put them later in the list, but they need to go in the order appropriate for their includes in this list. More V1, and now we come to the V2, the SNMP V2 standard section, where we include all of these standard V2 MIBs for you and make comments. RFC for our V3, the standard V3 MIBs. Then we include the open service MIB. We can include the SNMP research MIB, which gives us the NL ping capabilities. HP, if you're using it, is there, the OpenView NNM. .my, that is still a valid MIB file, even though it's in .asn1 format. Then here are the V2 MIBs from Cisco, the SMI V2 stuff. Notice that a lot of them are not commented out. You would go in here and uncomment these. They should be, and I repeat, should be in the appropriate order, but we cannot guarantee that things haven't changed. So if you have an issue, you may have to reorder these. Again, this refers to a directory structure. Underneath the MIBs directory where you currently are located, you will find these directories and these MIB files. Vendors / Cisco / then the name of the MIB. Vendors / Wellfleet / the name of the MIB. SNMP research, and that's the end of the MIBComp file, MIBComp.txt file. This is the file that you order so that you can compile your MIBs when you get a new one that you need to have NerveCenter look at. All of this resides in the MIBs directory, OptoSI NC MIBs. Notice the vendors, the standard V1, V2, V3 directories, and then vendors. And some of the vendors we have under there for you to look at, and you might want to compile, are 3Com, Apache, Bluecoats, Foundries, Fours, Chipcoms, Epic, all types of them. So they are here. I am sure that if you spend any time with NerveCenter, you will need to compile a NerveCenter MIB for some new device that you have that you want to work with. So, read the MIB, and at the very beginning of a MIB file are the includes. Probably should show you one of them. Let's look at Sun. Let's do a more on the SNMP DX file. Here's how a MIB is formatted. It tells you at the top, the double dashes, the hyphens, those lines are not included. This is a Sun Master Agent MIB, and here are the imports. These are the things that must be imported or included before you compile this MIB. It includes the term enterprise from the RFC 1115. It includes the object type of display string from RFC 1212. And then the Sun object identifier is enterprise, and so on. So there's only 2 imports here. This MIB can go anytime after RFC 1115 and 1212. These are the things you must account for, the imports, the includes. Every MIB should be written in a similar fashion so that you can find these imports right up front. You do it by doing MIBTool minus MIBComp, MIBComp.txt, and then change the output file. You modify the MIB name map.txt file to include the MIBs you want, and you order those MIB according to the imports that are listed at the beginning of each MIB. You run it, you stop NerveCenter, you copy it over, you restart NerveCenter, and you go about doing what you need to do with the MIB after you've done a MIB to group, so that we get those base objects into property groups so that the property groups have the base objects and you can work with them. That's the MIBComp. Reloading MIBs is, as I said, stop your server, make a copy of everything, copy over the new stuff, restart NerveCenter. Questions?